We are RANARA in BRITANICO and we're going to report about elemental analysis. Elemental analysis is a process of identifying the elements in an unknown organic compound. The purpose of elemental analysis is to determine the quantity of a particular element within a molecule or a material. Elemental analysis is independent of the structure, unit, or functional group. Elemental analysis can be subdivided into two ways. Qualitative analysis determines what elements are present or the presence of a particular element, while quantitative analysis determines how much of a particular or each element is present. In either case, elemental analysis is independent of structure, unit, or functional group. The elements most commonly tested includes nitrogen, sulfur, and the halogens. Carbon and the hydrogen are not tested for since all organic compounds are assumed to contain these elements. The presence of oxygen in a compound is better confirmed using tests for different functional groups in which oxygen is present. The objective for this experiment is to examine various organic compounds using preliminary tests to identify the solubility class of various organic compounds, and to examine and identify an unknown compound through preliminary tests and through their solubility classes. Listed here is the reagents used for this experiment, while here are the apparatus used in this experiment. There are many tests used in elemental analysis for the qualitative determination of the presence of the elements. Among these is the sodium fusion test. It is also known as the Lassaigne test. It is the most common method used in testing for the elements, and it is a general test for the detection of halogens, nitrogen, and sulfur in an organic compound. These elements are covalently bonded to the organic compounds. In order to detect them, these must be converted into their ionic forms. This is done by fusing the organic compound with sodium metal. The ionic compounds formed during the fusion are extracted in aqueous solution and can be detected by simple chemical test. The extract is called the sodium fusion extract or the Lassaigne extract. The element sulfur is tested using lead acetate. Sulfur combines with lead to produce lead sulfide, which comes out as a black precipitate. As a confirmation, sodium nitroprusside may also be used to detect the presence of sulfur. For lead acetate test, a formation of a black precipitate is a positive indication of the presence of sulfur. While for sodium nitroprusside test, a deep blue-violet color is a positive indication of the presence of sulfur. Nitrogen's presence in a compound is determined using the Lassaigne test. Under basic conditions, ferrous ammonium sulfate and potassium fluoride are reacted with the test mixture. The resulting thiocyanate ion is precipitated under acidic conditions and comes out as a Prussian blue solid. The Beilstein test is the most used procedure in detecting for the presence of halogens. Copper wire is heated and dipped into the test mixture for reaction. The different complexes copper may form with the halogens usually give a green flame when exposed to a Bunsen burner flame. Once the presence of halogens in a compound is detected, the specific halogen present may be tested for using silver nitrate. Silver forms insoluble solids with chlorine, bromine, and iodine with different colors like white, pale yellow, and yellow precipitate. Here shows the positive tests for halogens. A positive Beilstein test indicates a green flame. A positive silver chloride test indicates a white precipitate. A positive silver bromide test indicates a pale yellow precipitate. And a positive silver iodide test indicates a yellow precipitate. For the report outline, we are to write down the chemical reactions indicating the positive results for each test performed, and list down the limitations of each test and its conditions. Sodium sulfide formed during the fusion reacts with lead acetate to yield the black precipitate of the lead sulfide. If sulfur is present in the organic compound, Sodium fusion will convert it into sodium sulfide. Sulfide ions are readily identified using sodium nitroprusside. Sodium sulfide formed during fusion reacts with sodium nitroprusside to form a purple-colored sodium thionitroprusside. The carbon and nitrogen present in the organic compound on fusion with sodium metal gives sodium cyanide soluble in water. This is converted into sodium ferrocyanide by the addition of the sufficient quantity of the ferrous sulfate. Ferric ions generated during the process react with ferrocyanide to form a Prussian blue precipitate of ferric ferrocyanide. The sodium ferrocyanide reacts with the ferric chloride to form a Prussian blue ferric ferrocyanide. The Beilstein test confirms the presence of a halogen in a solution, although it does not distinguish between chlorine, bromine, or iodine. A copper wire is dipped into the halogen-containing solution and thrust into a flame. The copper oxide on the wire reacts with the organic halide to produce a copper halide compound that gives a blue-green color to the flame. If the organic compound contains chlorine, the sodium chloride formed during fusion reacts with the silver nitrate to form a white precipitate of the silver chloride. If the organic compound contains bromine, the sodium bromide formed during the fusion reacts with silver nitrate to form a pale yellow precipitate of the silver bromide. If the organic compound contains iodine, the sodium iodide formed during fusion reacts with silver nitrate to form a yellow precipitate of the silver iodide. Thank you for listening. This is Nicole RANARA and the next presenter will be Gyle BRITANICO.
We were asked about the limitations of each test and under what conditions that each test failed to give a true result. So the biggest limitation in classical methods is most often due to sample manipulation rather than equipment error, in which operator error in weighing a sample or observing an endpoint. So first one is the test for sulfur, the lead acetate test. So this describes a test for the presence of sulfur in materials. So this test involves heating a small sample of material in a glass pipette with a piece of moistened lead acetate test paper. It is a destructive test, but it only requires a small sample, which is about 10 milligrams. In the test, a flame is used to heat the pipette until the material under test gives off any fumes. So this is a sensitive test for hydrogen sulfide, so only a small sample is needed to produce detectable levels of hydrogen sulfide, and there is only a small amount of lead in the test paper. The TROLT from 2003 also recommends drying liquid samples such as white glue on a piece of aluminum foil for 1 day before testing. And the test papers need to be stored below 30 degrees Celsius in a dry place away from sunlight. If stored properly, they last several years. Nevertheless, it is important to check that the test paper still works by testing a known sample containing sulfur. And these should be free from any moisture, which may affect the true result. For the sodium nitroprusside test, sodium nitroprusside is very soluble in water, and only light-colored to clear solutions are the only accepted samples for this test. The presence of sulfur by the detection of sulfide ions through an intense violet coloration is highlighted in this part. So addition of too much nitroprusside may also tamper with the result. So a very dilute solution of such indicator shall only be utilized. For the Lassaigne test or the Prussian blue test, on heating of filtrate with ferrous sulfite solution, sodium ferrocyanide is formed at this, and at the same time, some ferrous ions are oxidized to ferric ions, and these ferric ions react with sodium ferrocyanide and then give Prussian blue or green color due to formation of ferric ferrocyanide. So if nitrogen and sulfur both are present in the organic compound, they may combine during fusion to form sodium thiocyanate due to insufficient sodium. This, when heated with ferrous sulfate, produces a blood red coloration due to ferric thiocyanate. But the absence of blood coloration does not necessarily mean that the sulfur is absent. This is due to the reason that the presence of excess of sodium thiocyanate, which will be decomposed to form sodium cyanide and sodium sulfide. So this test is not given by compounds containing N but not C atoms. Okay, for example, hydrazine does not answer this test despite of having an N atom because both C and N are required to form Cn ion. This test is not given by diazonium salts as they decompose to give nitrogen gas on heating. For Beilstein's test, this is employed to detect the presence of halogen in an organic compound. Okay, so this test is not very reliable because compounds like pyridine, urea, and thiourea, which do not contain halogens, also responds to this test. And it does not tell which member of the halogen family is present in the organic compound. The green flash is indicative of chlorine, bromine, and iodine. And this test is no longer frequently used because it is not widely used that it is possible to generate the highly toxic chlorodioxins. And the fluorine is not detected because of copper fluoride, which is not volatile. Beilstein's test is very sensitive, thus halogen-containing impurities may give misleading results. For the test for the presence for one halogen, which is the chlorine, bromine, or iodine, chloride ion may give a white precipitate, bromide ions may give cream precipitate, and iodide ions will give yellow precipitate. So they are halogens. And the halide ions in the solutions are detected using silver nitrate solutions. And the test solutions is acidified using a few drops of dilute nitric acid. And a few drops of silver nitrate solution are added. So nitric acid is added first to remove any carbonate ions that might be present because they would produce a white precipitate of silver carbonate, giving a false positive result for chloride ions. So further tests shall be accomplished for more conclusive results and to make sure if the element is truly absent or present within the unknown. It is also recommended to make 2 trials for each test to make sure that the results are consistent and would not be a false positive or a false negative. In the future, it is recommended to use stoppers on the test tubes, especially if they will be left in the open, as to make sure that no contaminant enter the system and ruin the results.